So in this video, I'm going to be showing you how to do binary shifts. So what is a binary shift? Well, it's actually quite a straightforward idea. It's basically where you move the bits in the binary number left or right. So why do you actually use this? Why would a computer want to do binary shifts? Well, let's have an actual practical look at this. So we're going to use this binary number, 00001100, so 12 decimal. And first of all, we're going to move it or shift it to the left, and we're going to do that by one place, and that's going to push it to look something like this, which is 24. Now we're going to take that same original number, 1100, and we're going to shift it right by one place. And what that does is that now gives us 6. So our original was 12, we shifted it to the left, we got 24, we shifted it to the right, and we got 6. So in other words, if you shift one place to the left, you double the binary number, and if you shift one place to the right, you end up halving it. So what do you actually need to be able to do? Well, the first thing is that you need to be able to explain that binary shifting is used for multiplication and division. The second thing you need to be able to do is say what happens when you actually shift a binary number left or right by a certain number of places. Then you need to be able to calculate what happens when you shift a binary number left or right. And then you need to be able to calculate what happens when you do a series of binary shifts. So you shift right by a few bits, you shift left by a few bits. So what happens if you do one after the other? So let's do some worked examples. So here's our first binary number, 52 in decimal. And we're going to ask a series of questions. What's the result of shifting left by 2 places to this number? What's the result of shifting right by 2 places to this number? And we're also going to ask, how can we halve this number and how can we multiply that number by 32? So let's have a look at the first one. So our original 52 gets shifted left by 2 places, and that's ended up by being multiplied by 4. We've now shifted it right by 2 places, and we've now divided it by 4. So in other words, if we want to halve the original number, we shift it right by 1. And if we want to do something ridiculous like multiply it by 32, then we're going to move it to the left by 5 places. 1, 2, 4, 8, 16, 32. So every time you end up doubling it. With the first time you double it, the second time double it again, until you end up with 32. So let's have a look at an example using multiple shifts. So here's our binary number, and that's 52 again. And we're going to apply multiple binary shifts. First of all, we're going to shift it left by 3 places. Then we're going to shift it right by 4 places. And then finally we'll shift it left by 1 place. So shifting the original number left by 3 multiplies it by 8. Shifting that number right by 4 divides it by 16. Shifting that number left by 1 place doubles it. So with this example we just end up with the same thing, but you can see the idea that shifting left or right, well, multiply it, divide it, depending on how many places you shift by. So this is a very, very typical type of exam question. So what's the effect of shifting any binary number left by 3 places, then right by 2 places, and then left by 4 places? Now, there's a lot of ways of doing this, and you might come up with your own faster way than this, but here's how I might break it down for you. So here's a table showing those shifts, left 3, right 2, left 4, showing what those shifts actually mean, and it's using an example number 10001 and showing what happens to that number. So what's basically happened to it is it's gone up to 32, so we've multiplied it by 32. So the results of those 3 bit shifts to any binary number is to multiply it by 32. So here are some exercises for you. And again, once you see the pause button, pause the video and have a go before you check your answers. By the way, if you look for binary bit shifts on the internet, you will find websites that will allow you to shift left and right, allow you to see what the results of those are. There's all sorts of websites that will help you do that and help you get an idea of what's actually happening in a slightly different way from me. And again, for the last 7, 8 exercises, 7, 8 and 9, you might find a quicker way of doing this than my way on the previous example. There are about 2 or 3 other ways I can think of. So here are the answers. Now questions 1 to 3, all of those were multiplied by 8. So 3 shifts to the left. Question 4 to 6, all of those were divided by 4. Two shifts to the right. And this is what they're looking for really in the exam, this idea that what's going to be the result of doing these operations. And again, pause the video when you see the button to give yourself a chance to review the answers. And that's all.